Here we go. P3 part 2. Okay. So we're going to talk about special products today. Special products, okay? If you can memorize these formulas, it's going to help you out a lot. Special products. Sum and difference of same terms. Yes. Okay, sum and difference of same terms. That's when I have something like u plus v times u minus v. Okay? What do I know if I have a plus times a minus with the same terms? What can you allude from that? What's going to happen? No. What's going to happen? Think about how we FOIL that. What's going to happen in the middle?
Oh, are we just simplifying it?
Yeah, they're going to cancel out. So when I look at this and see that this term and this are exactly the same, this and this are the same, but the signs are different, I know it's going to come out to say u squared minus v squared. Because the middle part, if I FOIL this, will cancel out. I'll get u squared minus uv plus uv minus v squared. This middle portion cancels. And you get u squared minus v squared. If you did that with numbers such as x plus 4 times x minus 4. Okay? If I did it with numbers, what am I going to end up getting? X squared. What is 4 squared? 16. Okay? So there I have this. This is a difference of squares. If I work backwards, this is considered a difference of squares. Okay? So that's the sum and difference of same terms. That one to me is probably the easiest. You can look at it and you should be able to tell how to do it. Save yourself some work. Okay? The next one is the square of a binomial. Square of a binomial. Okay? The square of a binomial says if you have u plus v squared in parentheses like that, it's always going to come out to equal u squared plus 2uv plus v squared. Okay? Always going to come out to equal that. So what happens is, if I worked this out, I would have u plus v times u plus v. So I would get u squared, I would get u plus v, and v squared. So whatever this number is here, u times v would multiply together to give me whatever that leading number is in the square. So I get that, and it turns out to be u squared plus 2uv plus v squared. If you did that with numbers, such as x plus 3 squared, okay, I'm going to get what for my first term? If I have x plus 3 squared, what am I going to get for this first term right now? X plus 3 squared, what do I get for that? X squared. I get x squared. Now, if I was FOILing, the next thing would be to do x times 3, which is 3x, and then I would do 3 times x again, which is, so it's whatever this number is doubled, is what goes here. Okay? So it's this number times 2. Whatever this number is times 2. And then on the outside, I get this squared. What is 3 squared? 9. Okay, so it's first term squared it's second term times 2 second term squared here. Now that is if you are doing an additional one. If I have u minus v squared, the only thing that changes is this middle symbol, okay? You would still get u squared, but instead it's going to say minus 2uv plus v squared. So I still have the same thing going on except for the middle changes to a negative, okay? So if I do that with numbers, such as, we're going to make this one a little bit more difficult, 3x plus 2 squared. What becomes the first term? Okay, well, 3 squared and what goes with that 3? The x squared. So what is 3 squared? 9. So you get 9x squared for your first term. The second term is these two multiplied together times 2. So what is 3x times 2 times 2? What is 3x times 2?
That's 6x.
And then 6x times 2 again.
12x.
12x. So is it going to be, oops, I should say. So then it's going to be minus 12x. Okay. And then the outside is what? What is the outside? What, Lindsay? 4. I'm just going to square negative 2. No, we're going to spell it like. Okay. Then you're going to do cube of a binomial. Okay, the cube of a binomial is, Lindsay, what we went over today a little bit. U plus v cubed. Okay, u plus v cubed. If I did that out, the first term is going to be u cubed. The second term is going to be u squared times v. And those add to give me 3 exponents, okay? So I'm going to end up getting, I'm actually going to end up getting 3u squared v, okay? Because I'm going to have 3 sets of those u squared plus v's because there's 3 binomials, okay? And the lead coefficient is 1, so in this case it's just 3. Then I'm going to end up getting 3 plus 3u v squared. I got to work my way down on those exponents. And then the last term is just v cubed. Okay? If we do that with numbers, x plus 2 cubed, what is the first term? X cubed. The next term, okay, would be whatever x times 2 is. Yes, this one gets tricky. So the next term is whatever x times 2 is, so 2 x, right? But you have to multiply it by 3 because there's 3 of those. So 2 times 3 is 6. So you get 6x squared. Now, this one doesn't look exactly the same as this. Technically, there's not another variable, so there's not another exponent, but there's always an exponent with a number, right? It's always to the first power. So that's where you get that exponent that adds to be 3, okay? So when they throw numbers in there, it gets a little trickier. The next one is then, you gotta keep working your way down, and it will come out to be 12x, and we'll show this the long way in just a second. And then the last one is always this last term cubed. What is 2 cubed? 8. Okay, if I worked it out and showed you how this worked, we would do it this way. You can always do it the long way if need be. X squared, 2x, 2x, 4, that gives me x squared plus 4x plus 4 times x plus 2. X cubed 2x squared 4x squared. Stop, Dakota.
It's on me.
It was 8x 4x 8. Okay, and then I would combine like terms x cubed plus 6x squared plus 12x plus 8. Same thing. This is just shorter. Where did I write? This is just shorter if you know the pattern. That's for an addition for a cube of a binomial. Let's talk subtraction of a cube of a binomial. So if you have u minus v cubed, okay, what do you think is going to happen in that first spot? U cubed. What do you think is going to happen in that next spot?
Probably u minus
Minus.
3v cubed.
Well, what happened here? U cubed plus 3u squared v. Same thing happens here. Same pattern happens here, except where the sign changes to a subtraction. Then, the next one, the sign is going to be what? Addition. It goes back and forth.
Where do the 3 come from?
Because, Dakota, when I multiply all of these out, I have 3 of them. So when you FOIL, you're going to end up getting like u squared v, negative u squared v, minus negative u squared v, minus negative u squared v. So when I combine them, I have 3. Because there are 3 binomials. Okay? And then the last term turns back to a negative. So it's the same pattern as the cube of a binomial with addition, except for my signs change on this one every other one. Back and forth, back and forth. Okay? With numbers, x minus 1 cubed, what comes first? X cubed. Yeah. What comes next? If this is just a 1 here, it's going to be minus 3 x squared. Good, Lindsay. Minus 3x squared. Then what comes next? Plus 3x. And then last, minus 1, right? Because 1 cubed is 1. Okay? So that is that. Let's look at, just look at my desk for a minute. Let's look at 2 more examples, and then I'm going to give you homework on just this stuff. Okay? Let's try factoring this. Dakota. Matthew. Oh, good. Okay. So that's the patterns we're going to focus on today. Let's try the product of 2 trinomials. I think you'll be okay with that. We've done that before. Let's do this. Let's do 6x cubed minus 4x. 6x cubed minus 4x. What comes first? What am I going to, I actually want you to do this. No. Think factor, we're breaking it down. You're factoring 6x cubed minus 4x. What can you take out of both of them? 2x. So if I take a 2x out, I am left with x squared minus 2. What is this here?
X squared.
It is a difference. Actually, it's not different squares because 2 is not a square, is it? So is that as far as I can take it?
Yes.
Yes, that's as far as I can take it. Oh, I'm stupid. There's there should be a 3 right here. This is a 6, not a. Okay, factor another one for me. We're going to do a couple more. Negative 4x squared plus 12x minus 16. Negative 4x squared plus 12x minus 16. Okay, what about that? Hey, do the last one for me and then I'll give you homework. You can take what out, Lindsay? I can take a 4 out. I'm going to take the negative 4 out so that that leading coefficient isn't negative. And I'm going to be left with x squared minus 3x plus 4. Can I factor that?
Absolutely.
Okay. How? What would I first do with the x's?
X.
X.
Okay. What multiplies to give me positive 4 but adds to give me negative 3? 1 and negative 4. Good. 1 and negative 4. What is, okay, so that's perfect. That's all I can do. Boom. Those are the things I'm going to have you focus on in tonight's homework.